Okay, so for today's lesson, we're going to talk about the volume of a prism. Okay, and for a volume of a prism, it's going to be the space that a figure occupies, and that's going to be measured in cubic units. Okay, so that's like units to the third power. So the formula is going to be the same for all prisms that we're going to use, but it's going to have to turn into something a little bit different depending on what the bases are. In other words, the formula for the volume of any prism is big B times big H. Now big B equals the area of the base. Now that base might be a rectangle, it might be a triangle, it might be a square, who knows. Big H is equal to the height of the solid. It's going to be that line segment or that edge that connects one base to the next. So for this particular prism, we need to determine what we're going to call the base. So I'm going to say that for this particular figure, let's talk about the bottom being the base. Okay? So if our base is the bottom, and again, we know that volume equals area of the base times the height of the solid. The bottom is a rectangle whose formula is base times height, and that's really going to be 13 by 6. Which in this case comes out to be 13 by 6, which comes out to be 78. Well, the height of the solid is going to be what connects the top to the bottom. The height of the solid in this case is 3. That's that line segment that connects our bottom to our top. Okay, so then what ends up happening is the volume then becomes 78 times 3, which means the volume becomes 234 inches cubed. Okay, let's move on to the next one. Here we have a triangular prism. And again, the formula for the volume of any prism is base times height. Understand, though, that the base is a triangle whose formula is BH divided by 2. Well, we don't have everything that we need because if I pull out that triangle, which is equilateral, we know that if I drop the height, my height is 10 rad 3. Remember, in a 30, 60, 90 triangle, which is what this becomes 60, well, it stays 60. This turns into 30. Your hypotenuse is 20. Your short leg is 10. And then, whoopsie, and then your longer leg is 10 rad 3. So when I deal with my base and my height of my triangle, my base is still 20. My height is 10 rad 3. Divide that by 2, and then what comes out here is I'm going to get 100 rad 3 for my area of the base. The height of the solid is that edge that connects triangle base to triangle base, which is 80. So then my volume, when I multiply 100 rad 3 times 80, gives me 8,000 rad 3 meters cubed. Remember, multiplying the height times the base. Okay, let's see what we got next. Find the volume of a right triangular prism whose sides are 3, 4, and 5, and an altitude of 8, as well as the volume of a rectangular prism with edges that are 2, 3, and 8. So I want a triangular prism first. So it's a 3, 4, 5, which means it's going to be a, obviously they told you anyway, but a right triangle. And we've got 3, 4, 5, right? So the volume equals the area of the base times the height. The base is a triangle whose formula is base times height divided by 2. 3 by 4 divided by 2, which equals 6. The height of the solid, which is the altitude, they tell you it happens to be 8. So the volume then I know is going to be 6 times 8, and I'm kind of running out of room here, so my volume equals 48. We know it's units squared. I'm not worried about that right now. Let's take a look at this prism. So, okay, so then we've got this piece down here, and it tells you that we've got the edges are 2, 3, and 8. Doesn't really matter what goes where. I'll put 2, 3, and 8. Again, the volume equals the area of the base times the height. I'm going to call my base the 2 by 3, which equals 6. The height of my solid equals 8. So the volume equals 6 times 8, or it's also 48. So it turns out that these prisms happen to have equal volumes. And two prisms have equal volumes if their bases have equal areas and their altitudes are equal. So if their bases have equal areas and their altitudes are equal. So while we have different dimensions here, their base areas right here were the same, and then the altitudes right here were the same. Okay, so two prisms have equal volumes if their bases have equal areas and their altitudes are equal as well. Find the area of the base of a prism if the volume is 42 and the height is 3. Well, again, prisms, volume equals area of the base times the height. We know that the volume is 42, and we know that the height is 3. What we don't know is the area of the base. Well, this is pretty easy. If you divide both sides by 3, then you get 16 equals the base, and that is the area of the base. We don't necessarily know what the dimensions are to get 16, but not 16, 14, I'm sorry. Sorry, 14. We don't know what the dimensions are to get 14. We just know that the area of the base, big B, is 14 units squared. Let's try this next one. If the base of a right prism is a rhombus with diagonal of 10 and 12 inches, and the volume of the prism is 60 inches squared, what's the height? So we know we're dealing with a rhombus, right? And we know that the volume is always going to be the area of the base times the height. And it tells you that the base is a rhombus. So the base, which is a rhombus, is diagonal 1 times diagonal 2 divided by 2. Which we're going to do here is 10 times 12 divided by 2, which ends up being 60. So that's going to be your base. And it tells you the volume happens to be 60 inches. So interesting here that we've got, it should be 16 inches cubed, by the way. That's a little mistake up there. So we know that the volume is 60. The area of the base is 60. What's the height of the solid? Well, that's kind of easy. The height of the solid happens to be 1 inch. Okay. This last one, we're talking about the total surface area of a cube, and then they want to find the volume of the length of the longest diagonal rod that would fit in the cube. In order to be diagonal, you have to go from the top of one base, or I guess we'll talk about the top of the ceiling, to the bottom corner of the floor. In other words, if we were to draw, and now this is my best attempt at a cube. But if we're going to draw a cube, the diagonal would have to go from the back top corner to the bottom front corner and go through that cube. Okay, that's what the diagonal is. And it turns out there happens to be a formula to find the length of the diagonal of a cube, and that's the longest segment anywhere in that particular cube. And it turns out that it's based off the Pythagorean theorem, because you can make these right triangles, a formula that you're going to need to know. So diagonal of a prism. And this is the formula that you're going to need to have memorized. And it's going to be the square root of the length squared plus the width squared plus the height squared. Okay, so this is a formula that's going to be memorized by you. And it's based on the Pythagorean theorem. So what's happening is they're telling you it's a cube. The fact that it's a cube, all the lengths have side of x. And they're also telling you, in this case, that you've got the total surface area. So let's kind of do this. We don't know the lengths of the length, the width, or the height. But we do know that the surface area is going to be 450 inches cubed. Well, squared. Surface area is going to be the area of one base times 6, right? Because there's 6 bases, and they're all x times x, or x squared. So surface area is like 6x squared. Well, we know that 450 is the same thing as 6x squared. If you divide both sides by 6, you're going to end up being 75 equals x squared. Well, we still need to get the length of the side of the square. So we're just going to kind of keep this in terms of radicals, and we're going to say that radical 75 equals x. So we're not going into simplified radical because it's going to be a little bit more difficult to do that. If we now think about the lengths of the sides, and I'm going to kind of go here, I'm sort of going to draw the corner, and we know that all of these pieces are radical 75, and we want to find the volume and the length of the diagonal. If we go for the volume first, let me kind of go up a little bit. So volume is the area of the base times the height of the solid. We know that the area of the base is radical 75 times itself, right? And then the height of the solid is also radical 75. Well, what happens is these first two radical 75s, anything multiplied by itself, drops out of the radical. The other piece stays under. And we know that radical 75, because here is now where we're going to kind of simplify this a little bit, becomes 75 radical 25 radical 3. 5 drops out. So the volume ends up being 75 times 5, or 375 radical 3 inches cubed. So that ends up giving you the volume. So we've got the length of the side, we've got the volume. All that's left to do is the longest diagonal. Okay, I'm going to bring this back up, and I'm going to bring this back down. Okay. So all that's left, I'm going to go for a new page actually. So all that's left is we now need to find the length of the longest diagonal. And we know that the dimensions are radical 75. We know that the diagonal has this whole formula. It's going to be radical, oopsie, I'll just do it this way. L squared, the square root of L squared plus W squared plus H squared. Which means when all of these radicals come in and get squared, what drops out in here is we're going to get 75 plus 75, which means we're going to have the square root of 225, which is just 15. So it's a 15-inch diagonal. Okay, that is it. So you should be fine, I'm hoping, with the homework. Good luck.